Yeah.
Yeah.
Okay. Actually, now let's start with drilling engineering. And I will just give you a general introduction, then I will go back to the syllabus. Now, I will start with the basic diagram that you will see in oil and gas industry again and again. Well, we usually draw reservoirs like this. Okay. And we are dealing with oil and gas. So our main target is we have the gas. Sorry, now we have the oil. Okay, now the first question I would like to ask from you, why the gas is at the top and oil is below?
Because
the
it's
oil
gas,
is
it's
heavy.
non-liquid.
This is one, this is,
Because it weighs
The,
less.
the oil is heavier.
yes, why? And there's third usually also, you can say water. This is the situation of every reservoir. Every oil and gas field has oil, gas, oil and water in this sequence. Why? Okay. Why? Because of the density differences. As you know, the gas is lighter. Okay. So gas stays at the top. Oil is moderate, stay in the middle. Water is the heaviest, stays at the lowest. You got the point? Okay. Now the second question is how many phases we have in the reservoir. We say this you see what the picture I have drawn. We call it a reservoir. Okay. If I write it here, we call this thing a reservoir. And to manage this one is a reservoir engineering. That we will talk in the other course. But right, our course is here, just the drilling engineering. So this is our reservoir, where we have gas, oil, and water. Now, I have oil company. Okay, what is my target first? Tell me, you are operating an operator here in Kurdistan. Which of the product you like to produce? Gas, oil, or water?
Gas and oil.
Gas and oil, but which one first and which one second?
And maybe oil. And
Okay, which one is expensive, gas or oil?
Oil.
oil.
Oil, first thing. Second, which one has a high demand here in Suleiman?
Oil.
Oil. So we need oil. Okay. Oil is our main product. This point of view is related with the demand. This is the demand. Second thing, in terms of the technicality of this reservoir, we would like to produce the oil because gas is creating a pressure, you know. Gas is causing the pressure for this oil to come out. It's like a piston movement. Gas is creating a piston-like movement for this oil, pressurizing this oil to come out of it. Okay, so that's the point. Now, this is the reservoir. Now we are here. We are exactly standing at this point. This is, we call it the surface of Earth. Or we can write Earth's surface. This is the Earth's surface. And let me draw. And we as a human, we are standing here. Okay. Now, let me make the hands also. My drawing is bad, but it's okay. It goes on. We are standing here. This is Earth's surface. And the distance from here to here, do you have any idea like how deep are the reservoirs? Anyone has any idea? In Iraq or anywhere else?
Like 2 to 5 kilometers.
2 to 5 kilometers, 2,000 meters to 5,000 meters. Well, yes, you are right. Your range is not that exclusively wrong. But any good reservoir is 100,000 meter and below. 1,000 meter and below. Here, sometimes even less than 1,000 here in Kurdistan. Okay, so easy to get out of. So now we are standing at the surface. We are enjoying our life here at the surface. The reservoirs are down around, let's say, 1,000 meters. I hope you get an idea how long is the 1,000 meters. Probably, from the entrance of AUIS to your classroom, let's say. So it's that deep. And now we are standing here. Oil is that deep. Is there any way to communicate with the reservoir? Is there any way we can, reach to this one? Is there any way?
Only by drilling.
Only by drilling. There's no way you can communicate directly with the reservoir. We can only reach to this oil zone just by communicating. Okay. Now, how we? Well, the first point is this is not not all the Earth is oil reservoirs. Not all the Earth. So what we do? I mean, who find out this place first? So this is the question comes in. So who do that? We have the geologists and the geophysics engineers. They have the exploration department, and they find out and tell us that, okay, we expect that there's an oil here, and proceed for drilling there. So then the drilling department get active. They go to the site and they start drilling there. That's how it works. So actually the answer is the geologist and geophysics, they decide. Now there's another discussion that we will discuss. There are two different kind of drilling wells exist. Okay, when we drill the first well, remember that I made this place here. From here to here, it looks like it's empty. Actually, it's all full of rocks. Okay, this one, these are the layer of rocks. They are not empty. So you can say sandstone rock, shale rocks. So these are not empty places, they are full of rocks. Okay. This is our situation right now. Now, geologist department told us that, okay, now you can, we have oil, please go ahead and drill the well. So now you see at the moment, do you see any well here? There's no well, right? There's no well drilled right now. So what we will do, we start the drilling process. We put our rig is a structure, which I will show you. It looks like this one. Sorry if my drawing is bad, but online teaching is like this. So we have a structure that I will show you later on in the videos also. We put a rig kind of a structure here, and we drill the well. We drill the well here. It is actually cleaning all of it. So I need to. Okay, anyway, so assume that this is all clean up here. I don't know actually how to do it. So we drill the well. Now you see that I draw actually 3 lines here, 3 sections. One is something like this. Okay, now we have a very clear well, a hole that is connecting this oil, and then later on this oil will flow. Now this oil will flow in this direction. Okay, now if you remember the drill machine that you use at your walls at home, that is you are just drilling probably a few inches, maybe 1 inch or 2 inch or 3 inch. Here we are talking about drilling 1,000 meters, 1,000 meters. And there are so many complications reaching from this place, from this point to this point. I mean, let's say it's 1,000 meter. It's not that easy. There are so many problems that we face. For example, number of problems we can say. You see the line here is straight. Maybe the well we are drilling, we have engineers who are lazy and they are not following it. So maybe the well goes like this in wrong direction. You cannot drill like this. It's going to, you know, stuck somewhere and you cannot proceed with it. Maybe you have some rock. Okay, these are the rocks. So maybe your rocks fall inside them and fill them. Maybe there's some problem and fill them. Maybe the equipment that you are using here, they get faulty. So there are a number of problems that exist during the drilling. That's why we, as a drilling engineers, are needed to drill the well. Okay, so that was a general introduction. So do you know what is rig? Anyone has seen the rig or visited the rig, or anyone has any idea about the rig?
You mean drilling rig?
Drilling rig, yes.
Isn't it the thing we use it to drill the earth?
Yes. Okay. Now I will show you one video of the rig. Then we will go back to the syllabus and tell you what we are doing and why we are doing in the syllabus. Okay. So any question from this for now? You got an idea? There is a reservoir. There is earth surface. The reservoirs are deep. We have to drill them. Drilling is 1,000 meter. It's a bit complicated. That's why drilling engineers are needed. We wanted to have a vertical well. By the way, this is called a vertical well. So any question regarding that?
One question, like before starting anything like a drilling, how do you know that places have an oil or gas?
Yes, yes. In that regard, there are the geology and the geophysics department. They do the exploration survey. Okay, what they do actually, they do the blasting, if you hear, or they do the dynamite blast. When they do the dynamite blast, it creates a waves, sound waves. And there are two kinds of sound waves, S waves and P waves. So what they do, they have the phones and recorder detectors. These waves, when they reflect back, so based on their velocity and time, they find out what kind of rock exists here. And they know this based on their experience. If the waves come, let's say in 5 minutes, this kind of rock exists. If waves come back in 7 minutes, this kind of rock exists. So they have a database that tells them that if P waves or S wave behave like this kind of reservoir exists. So what they do, these geologists and geophysicists, they are very much expert in their field, and they tell us that, okay, there's a chance that there's an oil. Remember, out of 10 wells, 3 wells are successful, 7 wells get dry. Okay, this is another thing. It's success story of the drilling. If you drill 10 wells, not all wells will be successful. 7 will get dry, 3 will get successful. It is because we are not sure exactly what is there. Okay, and there is one more term that I would like to clear. As you see that we had a reservoir, we draw a reservoir here, and we put one well here. Now this well, the one you see here, okay, is called the Wildcat well. It's a term that we used for drilling first well. So what is the Wildcat well? It is the first well drilled in the reservoir. Why we call it the Wildcat? Because we don't know what kind of rock we are going to encounter, what kind of problems we might face, what kind of pressures we might face. So we don't know what we are doing. We are just drilling wildly. We don't know what is going on in the first well. So that's why we call it the Wildcat well. We will talk about it in the presentations later on, but as a general introduction, we call it later on. Now then another kind of well is the production well. This is now the second well drilled in the same reservoir. Okay. Now, for example, we had this well is called the Wildcat well. Now, if we drill the another well here, another well here. Now, this well will be called the production well. So this one was the first well. It's a Wildcat because we don't know what is going on, what kind of properties we are going to encounter. So we call it a Wildcat well. Then this well is the production well, and now we know from this experience, we drilled this well early, and we know what kind of problems and properties we are going to encounter. So we just replicate the same data, we take it from here, we drill this well. So this well is drilling a bit harder because of the unknown uncertainties, but this well is quite normal because we know everything what is going on in this well. Now there's another question now comes up here. I made two drawings. I made one drawing which is straight pipe like this, but in this case I made first bigger hole, okay, then I made a smaller hole, and then I made the third hole. So there are three different kinds of holes in this one, and this one is only one. So which one do you think is the correct one, correct way of drilling? This one, this one. As you see here, I drilled two kinds. Here I just made one style. Let's say this, its diameter, let's say is 12 inch. Okay, but here in this case it was first 36 inch drilling, then it at certain level, then there was 24 inch, and then there was 12 inch. Which one is the correct way and feasible? Anyone?
Obviously the second, because the first one is you have to test it as well, right? This is why you go from 36 to 24 to 12, right?
Anyone else, please?
I think the first one, because you start, I mean, from my experience, when you drill holes, you start with a bigger hole and then you go smaller so that the drill can actually go in.
Anyone else? Okay. This does not exist. This does not exist. This is the right way. Because we are dealing 1000 meters, we have to save the cost. Okay. Drilling bigger hole needs more energy. Drilling smaller hole needs less energy. We have to reach the target zone. So we start from the 36, we end up with 4 inch or maybe 2 inch or 2.5 inch, let's say. Okay. That's the overall. So we start from 36, 3 feet, we end up with 2.5 inch. That's the maximum one. This is the correct way to drill the well. This one, no, it doesn't exist in our industry. The same diameter. We will keep discussing why and the problems and issues throughout this one. So now I'm going to close this one and go back to the real video of the drilling rig, and I will show you one. And then after that, we go back to the syllabus and we will end up this one. So let me save this one.
Last question.
Yes.
Do they start with wells straight away, or do they dig boreholes first? And what exactly?
Civil engineers comes and they prepare the site for us. The rig up procedure takes 2 to 3 months. Just to set up this rig, it takes 2 months. Okay, the preparation. And then the drilling engineers, they come, they start the drilling.
Okay.
It also depends on the location. Where was the previously located the rig, and the time, the location of the well. It's kind of an adventurous job. You will be in the middle of nowhere. Sometimes you will be working plus 50 degree, 55 degree. Okay, let's say in June. Sometimes you will be working in maybe, let's say in far places of Russia and China, maybe minus 45 degree, minus 40 degree. So be ready for a tough job. It's not that office job. This is a the field job, and the situation and environment is quite tough in terms of weather. So be ready if you can handle 50 plus degrees centigrade or minus 10, minus 15 degree. This is quite normal. Here in Kurdistan, you can expect at night maybe minus 5, minus 4, or 55, 52, degree, because you're working in desert, not in a city. So temperature in deserts are more extreme than the city. That's how it works. Okay. So now I will stop it here and go back to one video and get back to you on this one.
Can you see the video?
This is what they call a heavy collar. It's a big thick one here, very heavy. It goes on the bottom. And what makes up what they call the drill string, all of these pieces of pipe, the heavy collar and the drill bit on bottom is what makes up the drill string, which is all the pipe connected in a hole that goes down to drill the well. So you got the drill bit on bottom, a couple of stabilizers, heavy collars, and then the drill pipe. The drill pipe is laid out over here on these racks, and then they lay it up there on the ramp, and then they hoist it up. They put it in the wrap hole for the next piece. I'll show you that in a second. We'll go on up here. Over here we have the mud pumps. This is the doghouse, the derrick, crow's nest. Over there's a mud logger trailer. supervisor tool pusher trailer. There's my trailer. Come on up here. Fuel tank. Water storage under here. This tank on bottom. These are the hydraulics that control the blowout preventer. The rams, there's these rams that are in the blowout preventer that in the event of a blowout or something, the rams will close on the blowout preventer, and these hydraulics is what under pressure seals off the well. There's the traveling block. This big black hose has got mud going down it to the center of it. The mud travels through the big black hose, goes through the center of that Kelly, that square pipe, square piece of pipe. It's called the Kelly, and it's connected through the Kelly bushing to the drill string, the drill pipe, and it's all hollow. So the mud goes through the center of all of it, down to the bottom of the hole, flushes all the cuttings back up. Mud program is very important. It helps to more pipe. This is a tong right here, and over there is another tong. And the tongs are like giant wrenches that grab onto the pipe. They'll grab on the bottom of the pipe, the other one will grab on the top piece, and they'll unscrew or screw the pipe together using those tongs, those giant wrenches. This is called a draw works, this big blue piece of equipment. That is basically it's a giant winch, and that cable goes up all the way up to the top, the ground, comes back around, and that's the traveling block. So it's all a giant winch and pulley system that's supporting the entire weight of the drill string. And as you can imagine, the more drill string we add, the heavier the drill string is, the more weight on the bit. And so that's what this gauge over here is showing, the weight, how much weight we have on the bit. It's important to know that. All the cuttings and stuff fall out that way. Here's one of those tongs I was talking about, big giant wrench tong. Right on the bit. There's a slip. They'll use that in a minute as a wedge. They'll go down in the hole, and you'll see that in a second. Hold the pipe in place. It's a nice day. It's been